Okay, so let's start with this question. Question 1 from 2021-2022, test 2. Yeah, so the first question is a tennis ball of mass 40 grams moving to the right with a speed of 5 meters per second has an elastic collision with a target ball of mass 60 grams that was at rest. What is the velocity of each ball after collision? So you can imagine you have this first ball, this ball which has M1 collides with the second ball. So after this collide, it's moving to the right. This means it has a positive initial velocity. So after they collide, we don't know the velocity of the first ball and the velocity of the second ball. So this means we are going to use the law of conservation momentum. We're going to say M1 V1 initial plus M2 V2 initial, which equals to now we are saying that it underwent elastic collision. That means the two balls bounced off. So when they bounce off, they move at different speeds, different velocities. So we're going to have M1 V1 final plus M2 V2 final. So the question is asking us to find the final velocities of each ball after they collide. So that means we need to look for V1 final and V2 final. So we need to take note of the masses. The masses given M1, it's 40 grams. So we need to convert that 40 gram to kg. So if you convert 40 grams to kg, it's going to give you 0.04. So we're going to have 0.04 times the initial velocity for the first ball. It was moving to the right at 5 meters per second, so times 5 plus now what is the initial velocity for the first ball? It was at rest, so plus 0 equals to M1, which is 0.04 times V1 final, which we are looking for, again plus we have M2. The second ball has a mass of 60 grams. This means if you convert to kg, it's going to give you 0.06 times V2 final. So you need to simplify this. Let me just get calculator up. Okay. So right. So we can multiply 0.04 times 5, give us 0.2. We are going to have 0.2 equals to 0.04 V1 final plus 0.06 V2 final. So now we can divide by 0.2 just to reduce the things. 0.2 also here 0.2. So we're going to have 1 equals to 0.2 V1 final plus 0.3 V2 final. So here we have our first equation, like that. So here you have our first equation. So now the second equation is going to come from the elastic. Meaning elastic, it means this type of collision energy was conserved. So now energy conservation formula, we just need to gain this one, V1 minus V2 equals to, this is initial, equals to negative V1 final minus V2 final. So now we have V1 initial. V1 initial is 5 minus V2 initial 0 equals to V2 final minus V1 final. What I've done here, I've just multiplied this one plus this one times this negative, then this one giving plus, so I've just taken it the other side to have V2 minus this. So this is my second equation. So I'm going to solve this equation and this equation simultaneously so that I have V1 final and V2 final. So now I'm going to make V2 subject formula from here. So I'm going to have V2 final. V2 final equals to 5 plus V1 final. Now this one I'm going to substitute it in here. So I'm going to have 1 equals to 0.2 times V1 final, then plus 0.3 times V2 final, but V2 I have 5 plus V1 final. So 1 equals to 0.2 V1 final plus, should do, I'm not a calculator, 0.3 times 5 to give us 1.5. So going to have 1.5 plus 0.3 V1 final. So this is what we have. Now we can solve, we can collect items here. So we're going to have 0.2 plus 0.3. It's going to give us the papers. We are going to have 1 minus 1 minus 1.5. It's going to give us negative 0.5 equals to 0.5 V1 final. So we divide by 0.5, also here 0.5. So now V1 final is negative 1 meters per second. So we have the velocity, the final velocity of the first ball after collision. Now what is the final velocity for the second ball after collision? So you just put V2 final, where there is V1 final, you indicate, you put negative 1. So V2 final is going to give you 5 minus 1. So going to have V2 final equals to 4 meters per second. So these are the answers for the first question, and it carried 7 marks.